Um, Hello, everybody. My name is Anderson Cavalcante. I'm from Brazil. I'm a PhD student at Informatics Center at the Federal University of Pernambuco. Then my paper has the title, How Good is My Feedback? A content analysis of writing feedback. So feedback is an essential component of any learning experience because the feedback allows students to identify gaps in their learning and improve their self-regulation. Besides, feedback allows instructors to adapt their methods and content to students' learning needs. Uh, Feedback needs to provide relevant information related to a learning task or process and avoid the discrepancy between what a student understands and what a student should understand. So in online courses, providing feedback becomes difficult because instructors and students are physically separated in space or in time and or in time. One tool present in the learning management systems is the assessment resource. And in general, this assessment resource is the main space where instructors send feedback to students. Then the large number of students and the need continuous engagement, it's difficult for the instructors to provide high quality of feedback. This can cause problems in student learning and even lead to the decline of motivation. Then many researchers have proposed an approach to automating feedback for students with the aim of reduce instructor effort. However, their approach address feedback within a particular context, like introductory programming courses. Then the purpose of the paper and this work has two main objectives. The first is analyze the quality of feedback extracted from an online course offered by a Brazilian higher education institution following a model proposed by Hayden and Timper. Then the second is automate the classification of textual feedback messages in the four levels proposed by Hayden and Timper. The research questions and this paper proposed a content analysis using Haidt and Timper model as input and raising our first research question as to what extent can text mining methods accurately and automatically identify different aspects of good feedback process. Then the second research question is which features do best predict each indicator of good feedback? Then besides the automatic identification of good feedback indicators, we also intend to provide additional insights into the features that are more descriptive for different categories. Then here we have the Haidt and Timper model and that have four levels of feedback. The first is feedback about the task. Then we use the label FT to refer this label. The second is the feedback about the processing of the task. Then we use the FP label. Then the third is feedback about self-regulation. And we use the label FT. And the last is feedback about the self as a person. And we use the label FS for this label. Then the method is divided in these 5 steps. And the first is create a data set. We use a data set with 1,000 of teacher feedbacks from 2 online courses that are biology and literature. And the second step is the dataset annotation, and where expert coders classify the feedback. And if the feedback belongs to any of the 4 levels proposed by Haidt and Timper. Then the third step is the feature extraction. We use 2 main frameworks, the Luke and Cometrix. Then the fourth is the automatic classifier. We use a random forest algorithm. And the last is the results of the classification. We use the accuracy and kappa measures. The dataset, and it was obtained from a learning management system used in online courses offered by a Brazilian public university. And it was composed of textual messages that the instructor sent as feedback to the activities of their student. And a total of 1,000 feedbacks were collected. Then the dataset annotation, expert coders classify the feedback messages according to the 4 levels proposed by Haidt and Timper. The inter-rate agreement was moderate with percent agreement of 72.2% and coherence kappa equals to 0.44. And another 2 experts who didn't participate in the first step resolved the divergent case, 27.8% messages in total. Then we have this table shows the dataset division, and the FP level is the only one with balanced data. Okay, and the FR level, that is about the self-regulation, and this level had only 8 feedback examples out of a total of 1,000 feedback, which is not enough to fit a machine learning model. Then we didn't use this level. And how the FT level and the FS level are unbalanced, we apply the smooth algorithm. Then using smooth, we get a close number of examples for both classes. And since the FP level was already balanced, we didn't apply smooth at this level. Here we have 2 examples of feedback of the dataset. The first is good work, but it lacked the dialogue with the conceptions of language studied. And the second is regular work could have been richer and information on the topic, also lacking an introduction to make it more complete. Then the feature extraction, we use two main frameworks that are the Liuk and Comatrix. The Liuk extracts 7 for features of the text. Then the Liuk extracts a large number of word counts that are indicative of different psychological processes such as affective, cognitive, social, and perceptual. And the second is the Comatrix that extracts 48 features. Then the Comatrix provides several measures of text consistency, linguistic complexity, lexical category use, and others. And we extract 4 additional features: the number of named entities, the sentiment polarity, great presence, and positive expressions. The classification, we use the random forest classifier because it's a white box algorithm, and the data set was split into training 7% and test 30%. And the training was performed using the tenfold cross-validation technique. Then the results. For the FT level, this table shows the minimum and maximum values of the mtry parameter for the balanced data. And in the best case, mtry with the value 2, the classifier achieves 0.95 of accuracy and 0.91 of kappa in the training set. Then we apply in the test set the best model obtained in the training set. Then in the test set, we obtain 0.75 of accuracy and 0.30 of kappa. And this figure shows the performance of the random forest model using the optimal mtry value for different numbers of trees. And we can see that after 100 trees, the results remained stable. Then for the FP level, the best value for the mtry was 37. Then we obtain in the training set 0.81 of accuracy and 0.62 of kappa. And in the testing set, we obtain 0.64 of accuracy and 0.28 of kappa. And in this figure, we can see that the error rate had many variations between 0 and 400 trees. But after that, it converged. And for the FS level, the best value for mtry was 31. And in the training set, we obtained 0.97 accuracy and 0.95 of kappa. And for the testing set, we obtained 0.85 of accuracy and 0.38 of kappa. Then this figure shows that 200 trees were sufficient to ensure the convergence of the error rate. Then we also analyze the feature importance for the levels. Then this table shows the top 20 feature importance for the FT level, and the most important feature was the number of paragraphs, since the purpose of the FT level is to provide the students with corrective information. Then this feature is directly related to the amount of corrective information provided to students. And the second most important feature was the pronoun counting by phrases. And this feature was relevant due to the fact that the instructors use the personal pronoun in the second person to refer to the student. Then here we have the table that shows the top 20 feature importance for the FP level. The most predictive features of this category were the adverb and cognition mechanism counts. And these features are indicative of the richness of details in the instructor's text in feedback messages. And the text of feedback messages on this level provide more details in comparison with the FT level, because the FP level provides high-level feedback focused on the learning process and not only on a specific task. Finally, we analyze the top features for the FS level, and this table presents several features related to complements, because the FS level aims to provide feedback about the self as a person and provide motivation for the student using complements. Then the conclusions and limitations of this work. And the main contributions, we developed several binary classifiers to encode different criteria of good feedback proposed by Haidt and Timperley, and an analysis of the most important features was performed, and we explain the features that are more descriptive of each level of feedback. And the limitations of this work. One of the limitations is related to the data set, because the data collect are feedback messages from 2 online courses, and biology and literature. The study may not be fully representative of the different feedback in online learning course. And main feedback messages had similar text, because the dataset is from only 2 courses. Then the same instructor may have provided the same feedback to several students. And the FR level, that is the level about the self-regulation, and had only 8 instances from a total of 1,000, which was not enough to train a classifier. Thanks. Any questions?